everyone, welcome to yet another video series of organic light emitting diodes. So we have already seen about what is a LED, and we know that OLED is a type of LEDs. So in this video we will see what is meant by OLED. So organic light emitting diodes are an emerging technology in the display devices. The main principle behind the OLED is electroluminescence. It offers brighter light, thinner, it is very thin, and it has high contrast and has flexible displays. So OLEDs are basically solid state devices composed of thin films of organic molecules that is 100 to 500 nanometers thick. They emit light with the application of electricity. They does not require any black light. That is, they are self-emitting and they are made of carbon and hydrogen, and that is why it is called as organic LEDs. The first OLED was discovered by Eastman Kodak, which is named, who is a famous physicist, in the year 1987. In 1996, the Pioneer produces the world's first commercial PMOLEDs. So in 2000, many countries like Motorola, LG, etc. developed various displays, and in 2001, Sony developed world's largest full-color OLED. In 2002, approximately 3.5 million passive matrix OLEDs, which is the PMOLED sub-displays, were sold, and over 10 millions were sold in the year 2003, which is thrice as much as what have sold in 2002. In the year 2010 and 2011, many countries announced AMOLEDs, which is the active matrix OLED displays, and many developments are still taking place in the recent years also. So the main features of this OLED is it is highly flexible, and it is an emissive technology which weighs less and very thin in size, and it consumes less power, and also it has higher contrast, it is brighter, and is a perfect display from all angles. The main structure of the OLEDs consists of a cathode, an anode, which is being etched on a substrate, just like a PN junction diode. But in between the anode and the cathode, we have an emissive and conductive layers, which is made up of organic molecules or polymers. Now let's see how does it works. When the electrical current flows from the cathode to the anode through the organic layer, it gives rise to the electrons to the emissive layer, and it removes electrons from the conductive layer. So when a supply is given, the electron will move from the conductive layer to the emissive layer. So as we already know, whenever an electron moves from one layer to another, it emits some photons. So when removing electrons from the conductive layer, it leaves holes that needs to be filled with the electrons in the emissive layer. So when the holes jump to the emissive layer and recombine with the electrons, as the process continues, the electron drops into the holes. They release their extra energy in the form of light, which is the photons. So whenever an voltage is applied across the cathode and anode, a current flows from cathode to anode through the organic layers. Electrons will flow to emissive layer from the cathode. So the electrons are removed from conductive layer, leaving holes, and the holes will jump into the emissive layer, and hence this electron and hole recombination takes place, and which results in light emission. And let's see how this OLED is being manufactured. So the OLED is being manufactured in 3 different methods. One is vacuum deposition or vacuum thermal evaporation VTE method. The other one is organic vapor phase deposition OVPD method. The last one is inkjet printing. Now let's see what are the types of OLEDs. So we have 6 different types of OLEDs, which are passive matrix OLEDs, PM OLED, active matrix OLEDs, and transparent OLEDs, stop emitting OLEDs, foldable OLEDs, and we have the last one, which is the white OLEDs. So from the name itself, we will see one by one. Passive matrix OLEDs are, as the name implies, it is very passive. So which means that we have a matrix of cathodes and anodes arranged in such a manner that you have a pixel like structure. So in the upcoming class we will have a detailed discussion about this types of OLEDs. Thank you. Thanks for listening. Happy learning.